Okay, diving right back in. The 2A table shows that the number of births in thousands in the United States from 2010 to 2011. A baby is born in 2010 is randomly selected. What is the probability the baby was born in July? Again, what we really got to focus on a lot of times is just our reading skills, taking what's written and interpreting it with the table. So we're only concerned about 2010. In 2010, a baby is randomly selected. What's the probability that the baby is born in July? Well, if we can read it, it's going to tell us the answer. It's 346 out of 4,117. All right, so then we're going to have 346 divided by 4,017, and that's about 0.086. And remember, you can move the decimal places or thinking about timesing by 100, so 0.086 or 8.6%. Cool beans, right? Cruising right along, a baseball coach determines that there is a 90% chance that a star player, Kenny, will play in a tournament. The probability of another star player, Jim, will play is 28%. What's the probability that both Kenny and Jim will play in the tournament is 45%. Use the addition rule to determine the probability that either Kenny or Jim plays in the tournament. So we already talked about the addition rule once. Let's talk about it again. The probability that Kenny or Jim plays equals the probability that Kenny plays plus the probability that Jim plays minus the probability they both play. All right. And since we're given nice, crisp, clean percentages, we can just keep it as is. So Kenny, 90%. Jim, 28%. Both, minus 45%. All right. So what's that going to equal? Just bash it into a calculator. We're going to get some really cool number, and that cool number happens to be 73%. All right. So there's a 73% chance that one or the other plays. Cool. All right. A survey was conducted to determine whether a group of 11th graders and 12th graders preferred to go on an amusement park for the zoo for a class trip. The results are shown. Based on the table, what is the probability that a student preferred a class trip to the zoo given that they are in the 12th grade? So given that they're in the 12th grade, so notice how this doesn't have the total. So there was 50 total, 24 plus 26, 50 total. What's the probability they preferred the zoo? 26 out of 50. All right, which is 52%. All right. The zoo's a great place. One of my favorite animals. Some of my favorite animals are lions and alligators. They're great animals, but at the zoo they're kind of boring. Some good zoo animals. Everyone loves the otters. Those are always a great time. All right. Events A and B are independent. Probability A and B equals 0.15. What is the possible values for event A and B? So we have probability of A and B. All right. When independent, we have this very specific rule. And that specific rule is the probability A times the probability of B. All right. So using the given information, it says, well, the probability A times the probability of B equals 0.15. So this one we have to be a little bit clever. We have to be good with our number sense. We have to multiply two numbers together that equal 0.15. And the easiest way to do this is just pick 0.5, pick half, and pick a number that's doubled 0.15, so 0.3. All right, so basically there's a 50% chance, a 30% chance. If you multiply those together, there's a 15% chance of something happening. All right, so that's basically it. Very specific. You either know it or you don't. Probability A is half, probability of B is 0.3. And that would make this work right here. Very notation heavy, pure math on that problem. All right, this one right here, all we're gonna do is complete the two-way table, and then we're done. All right, so remember, just a bunch of addition and subtraction. Like in theory, I could start in either of these blue things right here. So that could be 33. I'm gonna be very tedious right here, make sure I check my work. What number, 20, we got this blank number here, 21, 33, it must add to 80. So I'm just gonna subtract 33 minus 21, and that's gonna be 26. All right, and then from here, everything starts to get crisper and cleaner. Like that has to be 8, that has to be 14, then this has to be 11, and again, just let me be exact with my calculations, try to have no mistakes. Something doesn't seem right here. Let's see for a second. Let me just double check my work. Oh, silly mistake. I know what I did. See, brain fart alert is I looked at, when computing this number right here, I looked at that accident. So my apologies, it should be 33 minus 19 minus 8. Let me clear that 33 minus 19. But this is a good thing. I was checking my work and I noticed my numbers weren't exactly adding up correctly. Now we're all good. All right, so I had a mistake, so this is a good thing to catch live on the video, but I double checked my work. All right, everything needs to add correctly this way. You add up all the numbers, everything needs to add up correctly. 18 plus 15 plus 14 needs to equal 47. 8 plus 6 plus 19 needs to equal 33. 26 plus 21 plus 33 needs to equal 80. And then everything needs to be true, adding straight down as well. All these numbers need to make sense. All right, so that's a great example. Check your work. All right, that's it.